Om Amriteshwari Namaha. My prostrations at the lotus feet of our Universal Mother Amma. We are not just gathered here on a lovely January day in an auditorium at Amrita University. We are all strapped in and seated together in a gigantic ball whirling around the sun at 67,000 miles per hour, nested in a galaxy. And despite all these whirling around and movements, you, the brilliant minds, the coders, the innovators, were so focused in nothing else but to solve the 12 challenges put forth. So a big pat on each one of your shoulders in adulation. Kudos to you all. You all deserve a big round of applause. The floor is all set now for the moment that we had been waiting for, the valedictory ceremony for the ICPC 2023. We understand the surge of emotions that you have had since last evening that could have been increased many folds now. So last few hours of the day, your brains were on JetBrains. JetBrains are the global tool sponsor of the ICPC. Well, let me not test your patience anymore, and I invite the Regional Contest Director, Swami Maheshwara Chaitanya ji, on the stage for the most awaiting segment of ICPC 2023.
Thank you, Srividya. Good afternoon. So we are ending the 2023 ICPC Regionals, Asia West, Amritapuri site. And as I mentioned yesterday, this is the first time after 4 years we are doing it in 3 sites. Of course, this is a team effort. And the first credit I will definitely give to Bala and Deepa, because they are working hard day and night to make sure that the platform works well. Apart from them, we always wanted to have quality set of problems. Another way to ensure that the Indian teams top in the world finals. So with regard to that, the key aspect here, I would like to thank the judges starting from Vichitar, Jatin Garg, Harshvardhan, Jay Sharma, Manan Grover, Nishang Suresh, Aryan and Yash Daga. One thing, as I had mentioned yesterday also, that the important aspect here is participation, not just being in the top, but whether you participated today by spending your 4 to 5 hours in front of the workstation to solve 12 problems. So that said, let us continue this session with the problem solution discussion. Let me invite Yash on the stage to start the first problem. Thank you so much.
Hello everyone. So we'll start with the hardest problem of the round. So as the problem says, you just have to go through all the images, and for each position you can maintain a 2D array where you count the number of occurrences where. Okay. Yeah. So you can take a 2D array and just initialize it with 0. After which you can just iterate through all images, and if there's a star, you can increment the count of that position with 1. And at the end, the count of planets is just the number of positions where the count is exactly equal to n, and for all the other places where the count is greater than 0 but less than n, that can be considered as a star. So it is not working. Okay, we can start the. In the second problem, you were asked to check whether it is possible to generate a sum n using k1 distinct odd numbers and k2 distinct even numbers. So for that, what you could do is first generate the smallest possible sum using k1 distinct odd and k1 distinct even numbers. So for that, you just have to take the smallest odd numbers and smallest even numbers, and you can calculate the sum of first k1 odd numbers computes to k1 square, and first k2 even numbers computes to k2 into k2 plus 1. You can compute this simply as a sum of series, and then you just have to check if s is greater than n, given n is the smallest sum, then it is impossible, and if s is less than equal to n, but the parity is different, so you can't change it. Then also it is impossible, because if you increase any number by an odd number, its parity will change, and the k1 k2 will not be satisfied. And if s is less than equal to n and parity is also same, then the answer is possible. And if the difference between s and n, you can just add it to the biggest odd or biggest even number. Apart from that, there was one catch, that the k1 k2's range was 10 to the power 18. So you just have to notice that you can't multiply and check, since it will overflow. If k1 or k2 is greater than 10 to the power 9, you can just simply say impossible. Any doubts yet? Okay. So for third problem, first you have to ask yourself the basic questions, that what is the minimum number of blocks which you require, and what is the maximum number of blocks which you can place. So the maximum number of blocks you can place is x into y, where x is the number of shadows in the horizontal line and y is for the vertical line. You can imagine this by imagining a grid which contains of x into y blocks, and apart from that, if you place anywhere, it will cast a shadow on a place where you are not supposed to cast a shadow, because then the coordinates will it will have a coordinate which is not belonging to a shadow coordinate. And for the minimum case, you can imagine by placing the blocks in a diagonal fashion, where in the sparse grid containing all the shadow cells, you start placing the blocks diagonally. So it will require exactly max of x comma y blocks. And to make it lexicographically sorted, what you can simply do is iterate it from left to right and top to bottom, basically lexicographically. And after placing each block, just check if the condition is satisfied, that k is greater than equal to max x comma y and k is less than equal to x into y, where x and y you can update according to the blocks which you have placed yet. So yeah, any doubts here? Okay, I would like to call Harsh to discuss the next problem.
Hi. So the next problem is, can we still qualify for the semifinals? So basically you are given entire round robin tournament, and basically you have to see if our particular team can qualify, in our case India. So we can divide it into two cases, basically, where the number of matches remaining are less than equal to 20 or greater than 20. So what we can prove is ki, if the next 5 rounds of round robin are remaining, that is like at least 20 matches are remaining, we can always make our particular team qualify. So in that case, like our problem is already solved. If our number of matches are less than 20, we can just brute force everything, and we can see, like, out of all these 2 to the 20 possibilities, can we make our team qualify? Okay. So, okay. Any questions regarding this? All right. So let's discuss cheap construction now. In this particular problem, we were given a sequence of insert operations in an empty sequence. You were asked to create an alternate sequence of operations where we create the exactly same resultant sequence, but the lexicographical order of these operations was minimum possible. So there are we can construct our solution in basically 2 parts. The first part is to actually construct our output sequence of what basically like hubs there will be. And the next part of the solution will be to find the lexicographically minimal set of operations in that sequence. So finding the final sequence is easy. You can use square root decomp, you can use like trees to do this. I think square root decomposition was like fairly easy to implement. And the next half of the solution can be done via. So basically, we want to find the lexicographical minimal set of operations. So we would like to insert the minimum possible element at the very beginning, and its last occurrence first, and then we can reduce it into like solving the left half first and then the right half first. So this becomes a recursive problem. So we can implement that via sectree, or RMQ would do too. Yeah, so that is explained here. You can use any BBS cell balancing binary search tree to compute CS, and then RMQ over it. Yeah. So next I would ask Manan Glover to join in.
So the next problem is symphony in C++ major. This problem was created by Kevin, and since he is not here, you can just read the solution because my rating doesn't allow me to understand it. Next slide. Just take a minute and read it. All right. I guess you can understand the to-do part. Let's move to the next. So, Super Mario. For this, first of all, we'll make both of the coordinates positive, because it doesn't matter which quadrant our final coordinate is in, because we can just shift it to the first coordinate. Then to move forward, we'll convert both of the coordinates in base k. This will be helpful in the later steps. Okay. So let's say if we want to reach a coordinate, let's say x star and y star, which is our final coordinate, it should be in the form such that each digit should be 0, 1 or -1. You can see that if, let's say, at some position x has 1 in it, it means that on that move we have chosen the right operation, because we have added k to the power the number of moves in the x coordinate. Similar for -1, we have chosen the left operation. For 0, it means that we were operating on the different coordinate. Okay, so yeah, that's the gist, that you have to convert it, the base k format into 1, 0 and -1. It is a little strange that you use -1 as a digit, but you can see that instead of using positive digits, you can also use negative digits. Right? For a special case in which we'll convert all the cases in, is when one of the coordinates, let's say x, is all 1 in base k. In this case, our final answer would be if x star is equals to x and y star is all 0 in the places where x was 1. Let's say x star and y star are of same length in base k. So that would mean that x star is x and y star is 0. To understand this, we can think it as ki, let's say if there's another answer, not x star equals to x and y star equals to 0. If we are trying to come closer to y star, we'll have to reduce from x star, because x star has the maximum possible value, all ones, and the amount you'll come closer to y, you will reduce it from x, which doesn't affect the answer. So the answer effectively stays the same if x star equals to x and y star is equals to 0. Okay. Now we'll see how to. It is not refreshed. One slide. Now we'll see how we'll convert every case into this format where one of the coordinate is all 1. Also, this goes same for if one of the coordinate is all -1, because this is the other edge. Okay. Let's say in the start we fix the total number of operations, let it be m, right? At final we'll iterate over m or something. Now we are iterating from m to 1, which means most significant bit to the least significant bit. Okay, so let's say I'm assuming that because we converted x and y to positives, which means the first bit cannot be -1. Let's say at mth position, the bit for x is 0 and the bit for y is also 0. We'll try converting one of them to 1 and other to 0. We can also do that to, we can also convert it to -1, but as both of them are positive, converting them to 1 would be a closer case to the final answer. So let's say x star is, we add x star 1 to x star and 0 to y star at the position where, at the mth position. So as we increased the most significant bit for x, we want to reduce the rest of the part to make it closer to x. Hence, we'll try to make every other digit as -1. So the answer would look like 1, -1, -1, -1. But yeah. So we'll try to make all the rest remaining bits as -1, and this converts to the case that I talked about in the earlier slide, where every bit is -1 or 1. So that solves this case. Similarly, for the other case, if let's say x is, the current position is more than 1, and we'll convert it to 1. And now, similar to the first case, we, instead of reducing x, we want to increase x. So we'll try to make the rest of the digits as 1, which again converts it to the special case. Also, you can see that we'll do this for both of them. First, we'll try for x, then we'll try for y in this step when we are at m, the most significant bit. Lastly, if let's say the current position for x is 1 and y is 0, there's a typo in it, it should be 0 for y. So if the current position is 1 for x and 0 for y, we'll just let it stay the same and move to a lower bit, because changing this would increase the distance from the final coordinate. So we'll keep it same and move to the next bit. Also, while moving to the next bit, we'll remove 1 and 0 from both x and y, and now it would be a recursive calculation. We'll follow the same steps for the remaining bits. And yeah, so the complexity for this would be, we'll try for every move. So we'll try for total number of moves जो final हो सकते हैं. That would be log of x, log of absolute value of x, because we are making it positive. So log of x, and after fixing the moves, the calculation takes another log x operations. I'm considering x to be greater than y. So this would be log square x. I think the constraints are in such a way that log square x might not work. So we can optimize it by seeing that what the total number of moves would be. The total number of moves, it is easy to see, would be the length of the x, or one more than that. Okay, you can just try some examples and you'll see the pattern. Yeah. For the next one, based on what? Also made by Kevin. So, yeah. Okay. Let's say x is 1, 1 and y is 0, 1. Let's take a bigger case. 1, 1, 0 and 0, 1, 0, let's say. So current position x is 1, the second position, and for y it is 0. So we won't make any change in this bit and remove 1 from it and 0 from y, 1 from x and 0 from y. And now the answer goes that we want to come near to 1, 0 and 1, 0 instead of 1, 1, 0 and 0, 1, 0. So we have just removed the entire bit from the start. So yeah. So if in the case where x is 1, 1, 0 and y is 0, 1, 0, x is already 1 and y is already 0. So basically we are moving a right operation on it. Any other question for Super Mario? So next, based on what? Again by Kevin. Read the slide. I'm sure it won't be as easy as it looks in just 3 lines. Oh, there's another slide, sorry. All right, we'll move to the next question. I'll invite Nishank for the next one.
Good job. Okay. So, how many people actually tried this problem? Okay, it's a good number. So the statement is you're given a string and you can insert at most k characters at one position of the string. You want to maximize the length of the maximal palindromic substring. As you can see, it's a string problem. So the solution is to first fix the midpoint of the final palindrome, which is either a single character or between two characters. And now you want to figure out whether, if you insert k characters somewhere, what's the longest palindrome you can get. For the k characters you insert, there are two possibilities. You either cross the center, in which case it's always possible to insert k characters, or you don't cross the center at all. So, so if you do cross the center, because you can, it's optimal to insert k characters which are equal to the reverse of some substring already present in the string. And because you're crossing the center, for example, so you fix something and you will have at most k choices for substrings ending there. Try all of them. Similarly, you have at most k choices for substrings starting there. Try all of them. Once you fix this, you have some part which is made a palindrome, and there might be some further extension. So you have some part already made matched with k characters. You have potentially something here and something here which might contribute to the palindrome, and you'd like to find the longest such length. That is a standard problem which can be done with a suffix array. And the second case is pretty similar. If the inserted k characters don't contain the center of the string, it is always optimal to choose the longest palindromic substring centered at that point, which as most of you likely know can be done with, say, Manisha's algorithm. But a suffix array can do it too. So the only issue here is that I'm guessing lots of teams tried hashing, and hashing is unfortunately too slow here. For whatever reason, the intended solution ran in like 1 second and hashing took more than 15. So there was no real way to allow it, sadly. But yes, so you will need a suffix array, longest common prefixes between adjacent elements, and an RMQ data structure on them, most likely as parse table to do it in constant time. Any questions? Well, I'm guessing hashing didn't work, so there are no questions. Right. Okay, so Christmas coloring, how many people tried this? There were a couple of solves, right? Yeah. So you're given a tree, each edge has a color, and your operation is you can choose a path on this tree, and for every edge on this path, either set it to the color or don't change it. And you'd like the minimum number of operations to color every edge. So obviously, because you can choose to not color an edge, every color is independent. So let's look at what happens with a single color. You can think of it as a tree where each edge is either 0 or 1. And if you look at what happens with all the ones, you will have something like a subtree. As in, not a subtree root related node, but just a subtree. And the optimal solution is, of course, if this tree has L leaves, you need at least ceiling of L by 2 moves to even touch all the leaves. And that will definitely touch every other edge in between. So that's all you need. So now, all that needs to be done is to maintain this quantity across updates. There are several ways to do that. I'll mention potentially the simplest one here, which doesn't need any extra data structures. So for each color, you store. One main observation is that if you fix a color, every leaf. So if you fix a color and root the tree, say at node 1, every leaf is either at most one leaf will be at the top of an edge. Everything else will be downwards. You can't have, say, 2 or more leaves which are both at the top of an edge. So the solution is to separately maintain all the leaves which are downwards and then separately check if there is one leaf at the top. To maintain the downwards edges, you perform a DFS, find the in and out times of every node. And now each update can be thought of either an insertion of that color or a deletion of that color. For an insertion, you need to check if the inserted edge is a leaf or not. It is a leaf if and only if there does not already exist a leaf in its subtree. And this can be done by binary searching on the in times to check if there is an in time in that subtree, which, as you know, forms a contiguous range. So if the inserted edge is not a leaf, nothing changes. If it is a leaf, the only potential change is that one of its ancestors, which was originally a leaf, becomes not a leaf. And to find this ancestor, you can once again binary search on the in times, because all you need to do is find the leaf, find an existing leaf with highest in time less than the node you insert. Because of the property of how in times and out times are laminar, as they say, as in they're either completely disjoint or contained inside each other, if an ancestor leaf exists, it will be this one. So you only need to check one candidate. Similarly, for the topmost leaf, it's easy to see that it needs to contain everything else in its subtree. So you might as well take the one with the smallest in time. This way, you only update like 2 leaves per update, which is all you need. So it's a couple of binary searches after DFS, so just log n per query online. If you'd like, you can also bash things with HLD or square root decomposition. It's more code, but it works. Any questions? No? Okay. Aryan?
So like, did anyone try this problem? Like that fake submission from IIT Kharagpur doesn't count. Okay, so the problem is expected diameter, and as expected from the problem statement, you are asked to find the diameter of a randomly generated tree where weight of each edge is between 1 and 2. And you are given the probability that what would be the probability of weight 1. So like the first step is to solve it for P1 equal to 1, that is the tree is unweighted tree, and you just select a random unrooted unlabeled tree. Like for that, and then you fix a diameter, and you can use brute force series to brute force and count the number of trees with diameter 1, 2, 3, 4 and all. And the next step after it, like the way I actually solved it was to just enter those numbers on OEIS. You will find some good generating functions over there, but be aware doing that in regionals would be considered as cheating. So like this is the link of an OES series, and you can also find a paper written in 1960 which was published in IBM journal over there. Like, the idea is unweighted tree. We first defined an exponential generating function which counts the number of rooted labeled trees with height less than equal to k. So here, like if g of k is a0 plus a1x up till an x to the power n, then the number of rooted labeled trees with height less than equal to k and n nodes would be an into the factorial of n. Like for the proof, you can refer to the paper given here. Now we are still solving the looks like some slides are missing over here. Okay, yeah, unweighted version. Like now we define h of k as exponential generating function counting the number of rooted labeled trees with height exactly k. Then we can again, like first, like where is g? Like a line is missing over here. Like how do we recursively define g of n? The idea, like there is a line, like I forgot the formula over here. Like you can, using g of k minus 1, you can find g of k by multiplying some exponentials over there. Like I will add it here and share the slides link on Codeforce's comment as well. Now you can also, like for the height exactly k, you can use g of k to find like the height is at max k minus the height is exact at max k minus 1. And if the diameter is even, then the diameter has odd number of nodes and center is one of the vertices. In that case, the center has 2 trees hanging to it with height d by, at least 2 trees height d by 2, and some of the trees with height at max d by 2. So let d equal to 2fm, then we can again recursively define an exponential generating function, like which would take g of m minus 1 is the function like when the hanging node has height at max m minus 1, and then we are finding the exponents of a polynomial to account for the case when there are at least two hanging trees with height at exactly m. Like exponent will give you like number of ways, like that can be 0, 1 and all, and you subtract 1 for the case where there is no tree hanging with height m, and h of m, like it should be m of x where the height is m. And if the tree is odd, then the diameter has even number of node and the center is one of the edges. So the case here is simple, like what we know is like both of the nodes hanging will have a height of m. So like exponential generating function for this case becomes h of m to the power 2, and by 2 is to account like both of them can be interchanged. Now coming back to the weighted version, like the idea is similar, like you will have more cases over here. If the diameter is odd, then the one possible case is like the center edge has weight 1 and it is same as the previous case. Otherwise the center edge has weight 2. In that case, like one side of the edge will have height m and other side of the edge will have height m minus 1. And you can multiply both of them to account for possibility of both of them. And now looking back to the other case, when the diameter is even, like instead of center node, we can also have a center edge with weight 2, in which case the tree will have the two trees hanging with height m minus 1. And if center is a node, and that the case is similar, like there would be at least two node of height m or height m minus 1, like we can also try over like the center is hanged with height 1 or 2 over there. So like first we try to find like what would be the height if there is like the first edge on that, like the edge attached from the root is of either weight 1 or 2. Like weight 1 would be like the rest of the tree has height m minus 1 multiplied by p of 1, accounting for the node which connects to the root. Or the hanging like root is connected with edge of weight 2 and the rest of the tree has height m minus 2. And then you use similar exponential generating function to count for it. One note over here, like some of the library implementation for exponential generating function works in order log cube of n, but there are ways to calculate it in n log square n. And so overall you would be finding this exponential like gk of hk of for all the order n possible heights from 0 to 2n. And for each of them you would be calculating exp, which will take n log n. So overall time complexity is n square log square n over here. And like I also saw one implementation which was claiming to be n log n, but I haven't tested it yet if it's actually n log n. Like these are notes by some Kevin, and I can share a slides where he have written like how do you calculate it. So any questions on this one before I move on to the next one? So moving to the next problem, critical construction. It was not solved it, and yet again my rating does not allows me to understand it. So you guys can read it. Like it says try small cases first for like for s equal to 1, s equal to 2, s equal to 3, so on, etc. Like as you increase the number of shapes, you keep on increasing the number of different cases over here. Like one critical step in Kevin's problem is like sometimes the expected solution can involve writing brute force code and hard coding it. And actually up to smallest s there are only few limited shapes that each by connected components can have. Although the number grows exponentially with x, for small s they can be enumerated offline. So define a function b of n as number of n node bidirectionally constructible graph. Once we have this function, everything else is relatively straightforward in order n cube counting dp, although we know how straightforward it was. And like the crucial part is computing some b of n function which he has defined over here. Need to compute b of n. For each s, pre-compute all possible topological shapes of BCC, backtracking s equal to 1, like he says count is 1, 1, 2, 5, 13, 15, something like that. Like you can just read it. So thanks everyone for joining.
Thank you, gentlemen. Is it on? Is it on? Yeah, okay. Thank you, gentlemen, for the solutions to the problem. From twinkling stars to Lego blocks to symphony to Pal World to can we qualify the semi-finals? You've heard the solutions to all the questions, to all the challenges. Thank you once again. And I request all the brilliant minds, the judges, to please come up the stage and grace the stage. Mr. Yash, Mr. Harshavardhan, Mr. Jatin Garg, Mr. Manan Grover, Mr. Aryan Chowdhury, Mr. Nishank, and Mr. Ashwin. I request the Regional Contest Director, Swami Maheshwarji, and our Principal, Dr. Sriram Devanathan, to please grace the stage. A huge round of applause to these brilliant minds. I request our Regional Contest Director, Swami Maheshwarji, and our Principal, Dr. Devanathan, sir, to kindly give the token of appreciation, gratitude, and goodwill to all the judges. A token of appreciation and goodwill from Amrita University. Ishwarji to Mr. Aryan. Mr. Aryan to please take over.
Hello. So like we would like to thank ICPC Live for sharing all the softwares you saw on the stream and like post contest solution reveal ideas. So like we will start with like winners, announcing the winners for all the problem, like who solved a particular problem first, and like the top 15 teams. We also have medal for them over here. Unfortunately, there was not a lot of activities between top 15 teams in the last hour or so. But looks like you guys made a lot of submissions in last hour. Yeah. And yellow is yet to be revealed. Yeah. So like, I think first we will jump on directly to the top 15 teams or so, something like that. Or probably let's see how it goes.
So you can see that like the submissions are getting simulated, like what happened after the last like 4th hour mark, like in the last 1 hour, like you can see what happened. The yellow ones are like yet to be submitted or judged, like because it was frozen, and red ones, you know, like it's wrong submission. Green ones were already accepted before it was frozen.
There are some funny team names over here. Okay, descendants of tourists, from NIT Rourkela. They were the first team to get an AC on the problem, and it was problem L. Looks like a big jump over there. ETH was nicely. There are some big jumps over here, like from 30 to 40, 10, something like that. And but I hope we did not disappoint you. So at 15th place we have Team TBD from IIT Hyderabad, bronze medal. They solved 5 problems over here. Can they come up on the stage to collect their medals? It looks like they are not here. It will be couriered at their home. Like 14th team is perfect error from IIT Varanasi, bronze medal, and they also solved 5 problems. Are they here? Looks like those guys are there. So we have now a segment track from IIT Kanpur. They also solved 5 problems and are ranked 13th. Are they here? मेडल भिजवा देंगे नाम लिख के. We will send medals courier at your home after adding your team name and on them, along with certificates and everything. So right now we would be recycling them. So don't mind. So the next team is from Kuera IIT Delhi, 12th place bronze medalist. They also solved 5 problems. Are they here? So the next team is Light Low from BITS Pilani campus. They also solved 5 problems and are ranked 5th. Are they here? Looks like they have left. So we will move on to the next team. Like, what do you think? Does this submission gets an AC or it fails? No predictions, anyone? Okay, we will let scoreboard reveal it. Like the team Flashpoint from IIT Kharagpur, 10th place. They were the first team to solve problem B, and they are the silver medalist over here. Are they? Looks like they are. topper from IIT Bombay. Again, any predictions whether they got an AC on this one? Well, let us see what the score will be. So they did got an AC on this one, so we will invite them later. So next is IIT Guwahati CNS Lenat Chiyatha with the silver medals. So I think are they here? They have also solved 6 problems and are ranked 7. Are they here? They were the first team to solve H&J problem. And like the strategy they are following in this contest is to go for hard problems first and easy problems. In this problem, like the last problem they solved was find whether Team Indian is qualified for the World Cup. And in online round, they were the first person to solve the hardest problem of the contest. And they were trying to do the same strategy in the Kanpur regionals, but it backfired. They are all So like they did not. From a long time, but I don't know what to do with it. And he tried it for 1 or 2 hours, simplified it, and in the end we would be using it as medium hard problem in ACE West. So like I would like to thank all the contributions he made. Like he's from Philippines, he's not here. And like let's move on to the last three teams now. Like although like you can obviously see like who would be the first, second and third over here. Because even if skill issue gets an AC on that, they would be at worst time penalty from like team Dunder Muffin from IIT Kharagpur. So like probably we can just start with the first team now instead of going from 3 to 1. Like can we have IIT Kharagpur on the stage? Would you like to say something about your strategy, like, or how does it feel like to be winner?
Why you are not on the top? Why you are not in this first position?
Our strategy was complex for a long time. As I think it was towards the mission of the team was
Intentional idea.
so it was intentional, yeah.
Next, can we have skill issue from IIT Delhi? Like they are the second team in this contest. Like we will reveal their submission. Okay, so I guess we will reveal it now. Like they did not got AC on this problem.
choose graph problems.
Like you guys could have also said हर बार IIT Delhi second ही क्यों आता है अमृतापुरी में. Like that's what Harshvardhan said last year when he was asked to say. So thanks and congratulations again. If I remember correctly, his statement was, yeah, bro यार हर बार एक रैंक से ही वर्ल्ड फाइनल्स क्यों रह जाता है. So like the last team we have is Team Leaf Papad from IIT Bombay. They were ranked third. Are they here? So would you like to say something for being?
Yeah, it's our third regionals, I think, and this is the only second time we three have sat together to do fourth region, and this is only the second time our team has participated in its full strength. So it really feels nice to take it home this time. Thank you.
So with this, like awards ceremony is over, like we will try to publish editorial of all the contests we have created so far. And like thanks everyone for joining. I will hand over the mic to Anand Sinai sir again.
Congratulations to all the winners and the contestants. With this, we come to the culmination of ICPC regionals this season with a promise of innovation and creativity in the subsequent times. At this juncture, on behalf of everyone at Amrita, I express immense sense of gratitude to our principal, Dr. Sriram Devanathan. Thank you, sir. He has always been a great support, great support, and have been a source of encouragement for any activities in our campus. Thank you so much, sir, for always being there. And a special mention, a special thanks, sense of gratitude to the Regional Contest Director, Swami Maheshwar Chaitanya ji. I request Maheshwar Chaitanya ji to please come up the stage, and I request our principal to please give a small token of appreciation to Swami ji. I would fail if I do not mention the name of our site coordinator here, Ms. Vinita. She has relentlessly worked towards this event, and it has taken the shape because of her. Thank you so much, Vinita. Thank you very much. Thank you, team of faculty members, staff. Thank you, dear student volunteer, dearest student volunteers. Thank you very much. Your enthusiasm has been really very infectious. Thank you so much. Gratitude to ICTS department, the logistics, estate office, electrical department, and of course, to the stars of the event, the contestants. Thank you all very much. I hope you had a great stay at Amrita here, and wish you the best and the brilliant life ahead. Thank you so much. God bless. Tea and snacks are arranged for you just outside this room. And yeah, we wouldn't make you wait like how it was yesterday. It's ready there. Thank you.